In this video, we will see how focal length of a convex lens can be obtained by UV graphical method and 1 by U, 1 by V graphical method. So these are the values obtained from the UV method. So we have an 8 set of values for U and V. So using this only we are going to plot UV graph. So for drawing an UV plot, we have to take U along the x-axis and the image distance V along the y-axis. So let us divide the quadrants into two. So then we have to take an appropriate axis. So here for our set of readings, so our set of U is in steps of 1. So we can take each centimeters at 1 centimeter. So the scale along the x-axis 1 centimeter is equal to 1 centimeters, that is 1 into 10 power minus 2 meters, and along y-axis also it is 1 centimeters. So each square boxes will correspond to 1 into 10 power minus 2 meters. The very important point to note in plotting UV graph is we have to take an equal axis on both the sides so that our UV curve will be a symmetric one. For example, the least reading for my U is 16 and the greatest value in V is 33.1. So if I start with 12 on x-axis, I have to start with the same on y-axis. So the minimum value for our graph is 16. So I am starting with 16 along the x-axis. In the same way I am starting with 16 in the y-axis. This is very important while plotting UV graph. You have to start with the same axis and the so next let us plot the points using the U and V values. So you will get a series of points like this, and next let us connect these points. So by looking at the points itself, we could see the point traces a curve. So one or two points may deviate from the curve. Let's not worry about these points. Okay, almost try to connect all the points which comes under a curve. You'll get a curve like this. Then we need to draw a perpendicular bisector. What is an angular, not the perpendicular bisector, it is called angular bisector. So what do you mean by an angular bisector? A line which divides an angle into an equal half, we call it as an angular bisector. See, to draw an angular bisector here from the origin, let us take a scale and keep it near the diagonals along the diagonals of the each corner of the square boxes. So it will be like this. So have a closer look at, we are joining the corners of the each square boxes, that is the diagonals of the each square boxes from the origin. When you draw, you will get an angular bisector from the origin which divides the 90 degree angle into equal 45 degree. So the angular bisector meets the curve at a point A, and draw a perpendicular from A to the x-axis and B to A to the y-axis. So the line meets the x-axis at point B, and the line meets the perpendicular meets the y-axis at point C. So you could see the point where B and C meet are equal on both x-axis as well as in the y-axis. So if you do not take unsymmetrical points, or you do not start with the same points on both x-axis and y-axis, you will not get the same value for the point B and C. Next, let us find what is the value of OB, that is the position of B from the origin O and position of C from the origin O. In both the cases, we could see the position is 21.3. So B is also at 21.3 into 10 power minus 2 meters, and C is also at a point 21.3 into 10 power minus 2 meters. So OB is equal to OC. Next, let us calculate the F using UV graphical method. So from the graph we could see OC is equal to OB is equal to 21.3 into 10 power minus 2 meters, that is 21.3 centimeters. Then F goes like this. F can be either OC by 2 or OB by 2 or OB plus OC by 4. We can use either of these three formulas to get an F. So OC by 2, we have the value 21.3 into 10 power minus 2 meters divided by 2. So the F will correspond to 10.65 into 10 power minus 2 meters. It's very simple. The calculation is very simple. So next, let us do 1 by U, 1 by V graphical method. So now let us plot. The very important thing here is to get 1 by U and 1 by V. We have the values of U and V from the UV method. So 1 by U. So it is our first set of value U is 21 centimeters, that is 21 into 10 power minus 2 meters. 1 divided by U, that is 1 divided by 21 into 10 power minus 2. This 21 10 power minus 2 in the denominator, when it goes to the numerator, it gives us 10 power 2 meter inverse, and 1 by 21 will give us 0.047, and all the readings tabulated here are corrected to third decimal and rounded off. So next, let us plot the graph. So here 1 by U is taken along the x-axis and 1 by V is taken along the y-axis. Here also we have to choose an appropriate the scale. So the scale on x-axis is 0.01 into 10 power 2 meter inverse, and along the y-axis is 0.01 into 10 power 2 meter inverse. So the measurements are made at an equal steps, or the readings 0.01, 0.02, 0. Each in equal steps of 0.01. So we have taken till 0.1 in the x-axis. In the same way along the y-axis also we have to start with 0.01 and till 0.10. So we have our set of 1 by U, 1 by V values, and if you plot it in the graph, you will get it like this. So all these points will stand on a straight line. They will stand on a straight line. Sometimes 1 or 2 points may deviate from it and deviate from the straight line. So let's not bother about it, and let's join the maximum point which fall on a straight line and extend that straight line to intersect at x-axis as well as in y-axis. We should be careful. This straight line which we draw is almost symmetric to both x-axis and y-axis. That means it cuts both x-axis and y-axis at the same values. In this graph you could see the straight line meets the x-axis exactly at 0.094 as well as in the y-axis at 0.094. So the point where it meets the x-axis we have named as A, and B, and under the y-axis it is marked as B. So from the graph you could see the values of OA is equal to OB. See, the B is meeting the y-axis at 0.094. So it is very clear from the graph. It is OA is equal to OB is equal to 0.094 into 10 power 2 meter inverse. So now let us do the calculation for 1 by U, 1 by V graphical plot. So from the graph we could see OA is equal to OB is equal to 0.094 into 10 power 2 meter inverse, and the formula goes like this. The focal length of the convex lens F is equal to either 1 by OA or 1 by OB. So the value of OA or OB is 0.094 into 10 power 2 meter inverse. If you do 1 by 0.094 into 10 power 2 meter inverse, you will get F as 10.63 into 10 power minus 2 meters. So we can tabulate the results, or we can present our results as the focal length of a convex lens by UV graphical methods F is equal to 10.65 into 10 power minus 2 meters, and by 1 by U1 by V graphical method, F equal to 10.63 into 10 power minus 2 meters. In both these graphical methods, we could see the focal length of a convex lens is almost the same. So in my previous video, we have calculated the focal length of a convex lens by calculation methods by using UV method and conjugate forcing method. There also we have obtained the F value closer to 10.6.